has projects in Narmada Basin of Central India, as well as collaborative projects in Maharashtra and in Sudan. His main interests are understanding prehistoric human behavior and adaptations through the study of stone tools, rock art, and vertebrate fossils. With this short introduction, I request Dr. Parth to deliver his talk. Now, today we have got Archaeology Day, so we have a eminent archaeologist to deliver a talk, and he has taken a very interesting subject, that is when archaeology meets geology. So I request Parth to deliver his talk.
Okay, thank you, Dr. Ajit, and thank you for inviting me to talk to this wonderful crowd. And I start my presentation now. Can everyone see the slide?
Yes,
Yeah, I can see this.
Yes, please.
Okay.
Nice
So
slide and full screen.
Yeah, full screen. So my talk is basically to give information on how archaeologists use geology and what benefits we can get from geology to answer specific archaeological questions. Now, archaeology spans millions of years, and I've only focused my talk to, restricted my talk to the prehistoric phase. I'm not talking about the last 10,000 years, Neolithic evidence, Harappan evidence, but mostly focusing on Stone Age evidence. But whatever I'm presenting, it can be applied to other time periods also, historical period, proto-historic period. But I'm giving examples only from the Stone Age. So understanding geology and archaeology, in fact, when you combine them, it's a special discipline called geoarchaeology. And this is where we use geological aspects or methods or perspectives to answer specific questions in archaeology. So three main reasons why we use geology in archaeology, why we need it, and we can't do without it. Number one thing is context. To understand the context of the site. How is it situated in the regional geology, on the local landscape? Is it a primary context or a secondary context? Yeah, how disturbed it is? Is it possible to excavate the site and date the site? And then another reason, of course, is using different geological methods to understand the age of the site. Without understanding the age, we cannot talk about the timing of transitions or timing of adaptations or specific timings of different technologies. So we need this information to not only describe the site, but also compare the site with other evidences in other parts of India and outside India. And the third aspect is environmental perspectives. So ultimately what we're trying to understand is how humans adapted to different environments over time. Why did different species change? Why did some species become extinct? How did Homo sapiens evolve? What animals became extinct and why? And most importantly, what environmental parameters was evolution taking place? For example, technological changes, biological changes, behavioral changes. How are all these things affecting human populations? So these are the three main aspects of why we use geology in archaeology. And I'm going to cover them one by one. Now, first, context. We need to understand the local geology even before we go to the field. In fact, I need to know the local geology to understand the context of the area before I can start surveying. So when I say contextual surveys, it means knowing the area slightly to look for the specific evidences I'm looking at. For example, if I want to find 1 million year old artifacts, I will only look for those artifacts in those contexts. I won't look for 1 million year old artifacts in 10,000 year old context. I should know the age of the ground surface, the age of the different geological layers at a broad level, whether it's Pleistocene age, Miocene age. So these are different geological time periods. Now, if I'm looking for Harappan sites, I will look for those sites in specific locations. They won't be everywhere. So different types of sites have patterns of occurrence depending on the context. So context can mean location, it can mean the different type of sediments, it can mean the layer in which the material is found, it can mean many things. So I'll give you examples of different contexts. So what are some of the questions we're trying to answer? The first thing we ask when we find a site or when we're looking for a site, and when I'm saying find a site, it can be a known site. For example, it was studied 100 years back, but now you want to go back and excavate the site and get new information. So where is the site situated on the landscape? Is it near the river? Is it near the hills? Does it have sediments? Is the site only in surface context, or is there evidence of burial? Are artifacts buried? Is it possible to excavate? And what is the associated matrix or sediments? Is it sand? Is it silt? Is it pebbles? And this makes a difference. And I'll explain that soon. Why the sediments make a difference? What is the local stratigraphy? How thick are the sections? Are the geological sections 1 meter thick, 10 meters thick? What is the local stratigraphy, and what kind of layers and what kind of sediments do they have? What is the size of the site? Some stone tool sites, it can be about 50 square meters, just a scatter of stone tools. And some sites can actually be site complexes. That means over 1 kilometer, you have artifacts occurring. So it's a site complex with many small sites and localities. And then what kind of typotechnology is represented? So in stone tools or any archaeological material, if you have lengthy sequences, you can use typology to understand the time period represented. If I find hand axes, then I know I'm looking at Acheulean site. If I find microliths, which are very small artifacts, I know probably I'm looking at a Mesolithic site. But it's not always the case. Sometimes you have mixing of evidence, sometimes disturbance in the sediments. And also, are there any fossils? Fossils will tell us a lot of information, which I'll talk about. But more importantly, if there are fossils, you can answer specific questions in relation to the stone tools. And you also have chance of finding human fossils if you find animal fossils. And then what are the patterns of vegetation, drainage? What is the location of the bedrock? How deep is the bedrock? What is the bedrock made of? And is it related to the archaeological evidence? Are there similar sites in the region? Or only one site is known, or maybe there's 50 sites in the region with the same technology? And also, are there any geological publications or archaeological publications available? Has anybody worked in this area before? Because that'll give you a lot of information and save a lot of time instead of doing all the work from scratch. So if you have a lot of background evidence available, then you can contribute more by taking things further. You can also confirm whether the previous research is correct or it needs more research, for example, with new techniques. Is a site in danger of destruction? Is it near human development, for example, or is it inside the forest? If it's inside the forest, then we don't need to work urgently. But if it's going to be submerged, for example, inside a dam construction, then we have to work fast. So in a site where we have to work fast, we can't do everything. So then we have primary sites versus secondary sites, very broad categories. First of all, you have to keep in mind, there's no such thing as 100% primary site. Every site we find, every artifact we find is disturbed at a minimal level. Imagine something you drop today, for example, a pen on the ground. If you're walking somewhere, you drop a pen on the ground, that pen is not going to stay in the same position for more than a few minutes or a few hours. Somebody might walk on it. somebody might kick it, or there might be heavy wind or rain is going to shift the pen. So a lot of factors affect these sites. No sites are 100% primary. Majority of the sites are secondary context, and primary sites are mostly in context of low energy. And what do I mean by low energy? I'll explain in a few slides. So what are the hints of primary context? How do we know something is less disturbed? One is that artifacts will be fresh, especially stone tools. Artifacts will also be abundant. Associated matrix or sediments will be clay or silt or sand. If you have gravels like pebbles and cobbles, then it's probably not primary context. And then sometimes you find artifacts in the surface or excavations, and they're refitting together. If they're refitting together, it means the site is not disturbed. Also, if there's association with fossils, because fossils form in very unique conditions. The geochemistry has to be right. They would have been buried quickly after death. And then they have been exposed recently. If they were exposed 100 years ago, then the fossils would not survive on the surface. So the fossils also tell us a lot of information about contextual integrity. So looking at sediments, we have various sizes of sediments. The smallest particles you can see is clay on the bottom, then silt, different sizes of sand particles, then granules, and finally pebbles. And what do we have after pebbles? For example, this is a pebble. I'm showing you here on the screen. This is pebble size. But anything bigger than this, double size, would be a cobble. And anything bigger than this size would be a boulder. So you have the different sizes of particles depending on the energy of deposition. If the river is flowing gently, you're going to get clay, silt, and sand. But if you go to Himalaya and you see the gradient is high, the slope is high, and you have water rushing very fast, you're going to get pebbles, you're going to get boulders and cobbles. So any archaeological material that is found in these different types of sediments, it tells a lot about the context, whether it's worth studying further, whether it's not worth studying further. So gravels or conglomerates include pebbles, cobbles, boulders. And because they have large clasts or large rocks, it means it represents high energy of deposition, and it's probably secondary context. It can be deposited through fast-moving river on a high gradient, or even through colluvial processes. And when I say colluvial processes, I'm talking about rocks slowly shifting or sliding on the ground over time. And that is colluvial activity because of gravity. From a higher elevation to a lower elevation, the sediments and rocks are slowly shifting. It can be 1 centimeter per week. It can be 1 centimeter per day. It depends on the process, on the amount of inclination. Many things are affecting these things. Here's an example of what gravels look like, gravels and conglomerates. So first thing you notice, most of the rocks are rounded. If they're rounded, it means they were deposited by a river at one time. If you find them as angular, that means they're close to the source of the original source. It could be near bedrock, for example, or they didn't get a chance to get deposited into a river. So you have to look at the angularity, whether it's highly rounded or less rounded. And that brings me to the term fluvial context. Fluvial context is any context related to water. For example, all the streams or rivers will transport material from higher elevation to lower elevation. And archaeological sites can be found along any of these areas, close to the mountains, in the middle part of the valley, or even by the delta near the coast where you see it's meeting the sea. So it depends on where humans settled. And different types of sites are found in different types of locations. So we look at all these locations to understand patterns, because ultimately in the past, even today, geology and geomorphology have patterns. Climatic patterns are there, environmental patterns are there, seasons are there. All of these things affect the vegetation, the topography, the animal life, everything. And those things have affected archaeological settlement and adaptations. So if we can find the patterns in the past in the natural world, we can probably find patterns in human behavior. Here's a fluvial section. So when a river is flowing, it's going to shift course. Sometimes it's going to be flowing here, but 10 years later, it can be flowing 500 meters away. Many of you are familiar, this happens very commonly in, for example, Ganga Valley. Ganga Valley, last few thousand years, the river has been shifting the course. So it keeps cutting the sediment, its own sediments. In a flood environment, it deposits the sediments, but during the monsoon, it cuts the sediments. So it does two things at the same time. And this is a section showing a fluvial context. On the bottom, you have sand or silt, which is a low energy environment. In the middle, you have the pebbles. That shows higher energy. So why are there pebbles suddenly? What is the reason for sudden change from low energy to high energy? Is because there was probably some activity upstream, like tectonic activity, like an earthquake or something, that affected the gradient and brought all the rocks down from a source. Before that, the gradient was gentle and there were no rocks. Here we have lake sediments. Lake deposits are very unique. What happens in a lake environment does not happen in a stream environment. So you have a lake which is gentle water, there's no flow water, and you have particles of sediments or dust falling into the lake, and then they settle down vertically without any disturbance. So you can see here layers have been created, and these layers can represent, for example, 1 year or one season or 5 years. There's a sequence of layers, and you can study it in a very high resolution manner. But in a river, you cannot study in a high resolution manner because sometimes it's flowing too fast. Layers are missing. It not only deposits sediments, but it also cuts sediments. So sometimes in a river section, the specific time period could be missing. 50,000 years could be missing. 1 million years could be missing. But in a lake environment, usually, almost the entire time period is preserved. Then we have very interesting type of sediments called loess. Loess deposit is basically dust particles, especially in glacial zones. In the glaciers are made of ice, but inside the ice, you have dust trapped when the glaciers were forming. And when the glaciers start melting, that dust from the glaciers, it gets into the atmosphere and deposits everywhere over time. So here we have very thick meters of loess deposits. And archaeological sites are also found in this context. And this is very good for dating purposes, for understanding the ancient environments, many benefits of this kind of context. Now, I want to give you some case studies of where geology has been used for interpretations from others' publications, from my own publications. So this is an example of the work done by Corvinus in Nepal. And she worked in the Shivalik Hills and found artifacts embedded in these layers. So you see on the bottom right, there's a photograph showing the location of artifacts, these hand axes. And based on the geology and local stratigraphy, she could find out that this hand axe was actually discarded before the layers became diagonal. At one time, these layers were horizontal. So deposition was happening. It was a normal landscape. Then the artifact was just discarded. And then because of tectonic activity, it got uplifted. So the artifact also became uplifted with the layer it was in. Here's another example from my PhD area. You see on the top photograph, these vertical layers. And on top of that, you see the horizontal layers. So the vertical layers are actually shivalic sediments. And the horizontal layers are actually post-shivalic. So what happened is after the layers became vertical, at one time they were horizontal, then the shivalics uplifted, the sediments became vertical, and then there was another depositional phase with horizontal sediment deposition. And you can see the close-up on the left, bottom left. Sand is there, conglomerate is there, and on the bottom, shivalic sediments. So this shows example of a combination of upliftment of the sediments and cutting of the sediments. And if we reconstruct this situation, this is how it was. So number one shows the landscape before human occupation. It was all flat. There were valleys, grasslands, forests, animals, millions of years ago, but no humans. And then maybe about 50,000 years ago, everything became uplifted. And number two shows evidence of human occupation. So the red dots you see are the artifacts. The black dots are the rocks. And the yellow area, the yellowish color is the sediments of the river coming out of the hills. And then this continued to uplift further. And then everything became dissected from weathering, erosion. So today, the site looks like number three. The yellow sediments are uplifted. The artifacts are uplifted also. Everything is now up and down. At one time, everything was flat. And that's how it can affect interpretations. Archaeologists can actually misinterpret these kind of situations if you don't know geology. If there is no geological input, we can actually misinterpret. For example, when this happens, you have the landscape changing so much. So what happens is you have animal fossils embedded in the shivalic sediments on the bottom, but then you have younger artifacts on top. And because of the disturbance, everything became mixed. So you have this situation where you have stone tools mixed with animal fossils. If this was not disturbed context, if it was an undisturbed context, then we can say maybe that this represents evidence of hunting, of butchery, of meat eating, because you're finding artifacts and animal fossils together. But in this case, the stone tools are younger and the animal fossils are older, and they became mixed because of geological processes. So you have to know geology very, very well at a basic level to make sure that you're not misinterpreting or misreading the evidence at the site. Now, coming to some examples from my area in central India, I work in the Narmada Valley in Madhya Pradesh, and this is how a section looks along the river. And this shows the fine sediments. It shows that it's a very low energy deposition. It has fresh artifacts coming out of it. It has the shell coming out of it. And the shell, you see that on the top left, is a good indication that it is a low energy environment. That means it used to be a swamp or something. A similar section, and this is older, you can see the change in color. Now this section is brown, less iron content, but this section is red. It's reddish or orangish. It means it has more iron oxide. So this climate was different at this time, but in the earlier section, the climate was different. So the color of the sediments give a broad hint and other information of course, that what it was like. And how do we study these sections? We study them like this. Very high sections, we dig step trenches. As you can see the steps here. That's why it's called a step trench. So we don't need to dig large trenches like archaeological excavation always. Archaeologists also dig small trenches. Even though it's deep, it's 10, 15 meters deep, it's very narrow, half a meter narrow. So this helps us in sampling for dating purposes, for other scientific analysis, looking for artifacts, understanding the layers also. How many layers are there? And here's an example of a stone tool eroding out of the sediments. And why I say eroding out is because at one time, this area was not disturbed. The artifact was completely buried. But now because of weathering and erosion, it's coming out gradually. This happens because of rainfall, human activity, or the river is flowing and cutting the section more. Imagine a cake with different layers. As you make a slice into the cake, there's different layers visible. The river cuts the sediments just like a slice of cake. So all the buried stone tools, fossils, everything comes out. Here's another example of a hand axe, very large hand axe, excavated after it was found in the section. And we try to understand the type of sediments it's embedded in, whether it's clay, whether it's sand, gravels. Here's another example, very small hand axes, again in this sandy, pebbly gravel. So it tells us also the environmental deposition. How do these artifacts end up there? And what is the benefit of this? Even though the gravel sometimes are secondary context, the gravels have one very useful benefit. If you find artifacts in the gravel, we know they are disturbed. They came from somewhere else, but that's the benefit. We know that the primary context is upstream. We have to walk the river or stream upstream and find the original context from where the artifacts are coming out. So secondary context helps you find a primary context. Here's an example of artifacts associated with animal fossils. And from the sediments, you can see this is a very less disturbed situation. First of all, there are no pebbles or cobbles. Second of all, the artifacts are very, very fresh. Fresh meaning they're sharp. If the artifacts were rolling in the water for a long time in the river, they would not be sharp. The fact that they're sharp suggests that they are less disturbed. Complete opposite situation. This is an example of a secondary context. You have the fossil in the center, and on the top right, you have a purple artifact. So you can see all the pebbles are there. First of all, we can see the hint. The pebbles are there, cobbles are there, and all the specimens, the fossil also and the artifact also, they're not sharp. They're rolled condition. So this shows that there is a secondary context. Very disturbed. Everything's mixed. Most probably, the fossil is a different age and the artifact is a different age. They're not contemporary. This is another example of how we find sites. Now, in many areas in India, in the world, the sediments are mined. There's a lot of quarries. So rocks are mined, sand mining is going on. This laterite is mined, especially as murum. So wherever we find these quarries, we investigate them to look for artifacts. So on the one hand, these activities are destroying sites, but on the other hand, they're exposing sites for archaeologists. So here you have laterite forming on top of the Vindhyan bedrock, and on top of that, you have a gravel with artifacts. And here is a close-up. All the gravels are there. And what do you notice? One thing you notice about the rocks, all the rocks, some are rounded, some are angular, some are semi-rounded. This shows that there's a mixture of elements, and these rocks came from nearby sources. If they came from far away, all of them will be very rounded, like the gravels. But in this case, this is a regolith and not actually gravels. So you have artifacts, you can see by the arrow, very fresh stone tools coming from a regolithic context. And sometimes, if we're lucky, we can have dating samples from the regolith and get an age a rough age for the archaeological evidence. And then we have other types of context, cave context. This is very different. This preserves material better. The layers are better preserved. Organic material like bones, charcoal, pollen, these things are better preserved in a cave context. The only problem is sometimes some caves are difficult to excavate. They're very humid, or constantly there's water on the cave floor, or there's bats. There's various issues with caves, but they are good for better preservation. Here's examples of some caves of where human fossils have been found in China. So you can see some caves are very small and very deep, but still they're finding human fossils. And complete opposite example, I'll show you from Southeast Asia, the cave of Liang Bua, very large cave. See the number of people inside this cave. This is where they found fossils of a ancient human, Homo floresiensis, and stone tools. It was preserved because it's a cave context. If this individual died in the open landscape, there's less chance of preservation and fossilization. Now, some of you are familiar with this photograph, maybe. This is showing Bhimbetka, a famous rock art site in central India. Now, I want to show you this photograph because this is a rock shelter. It's different from a cave. A cave is deep, but a rock shelter is shallow. So this shows that you have different types of context. All the elements are affecting the deposition, occupation, the preservation. And then we get to the age. We're using geology to actually get age. Most times we're not dating the artifacts. We cannot date the artifacts directly. We date the context of the artifacts, the matrix or sediments that is encasing the artifact, the layer. So we get a minimum age of burial, because sometimes you might have artifacts lying on the surface for 100 years before burial, or sometimes they were on the surface for 10,000 years or 5 years before they got buried. And we can also sometimes use organic material or pottery from young sites for dating directly. Now, just a very general introduction to dating. We have two types of dating: absolute, which tells us the exact age of something, and then relative dating, which tells us approximate age, whether something is older or younger than something. I'll give you some examples. Relative dating, we have law of superposition, biochronology, paleomagnetic dating, typology, fluorine dating. So these are very, very simple concepts. Law of superposition means the oldest material is on the bottom and the youngest material is on top. Biochronology, we use fossils to give approximate ages to layers. For example, if we know an elephant species lived during the Pleistocene, then we most probably the context we find the fossil is not Miocene. So we can do deductive reasoning based on the fossils. And typology is looking at the way our artifacts change over time. If we get very crude hand axes, very large and thick, we know they're probably older. If we get symmetrical and refined and thin hand axes, we know they're probably younger. And then fluorine dating, amount of fluorine, the older the fossil or bone, the more fluorine it has. And then I'll talk about paleomagnetic dating here. Now, all of you know that when we use a compass, the needle, it points north. But in the past, and also in the future, the needle pointed south. That means the magnetic polarity changed in the past, and it's probably going to change in the future as well. We don't know why this exactly happens, probably something to do with tilting of the earth. But what is interesting is that the transitions of normal polarity, which is north, and reverse polarity, which is south, these transitions were not regular. As you can see, the black and white sections here, these are showing reverse and normal. So the black ones are normal and the white ones are reverse. You can see the duration vary. So if you take samples of sediments and see which directions the particles are facing, pointing in, and if you have a very long sequence of these samples, then we can work out where we're looking in the time period, where the archaeological evidence or fossil evidence belongs to. It could be within the Matuyama, it could be within the Olduvai event, it depends. But we need a very lengthy sequence and many, many samples. If you just have a 1 meter section, and if you find evidence of normal polarity, how do we know whether it's part of Bruns or whether it's part of Gauss? Because both of them are black, both of them are normal. So once we have a lengthy sequence, we can see which is normal, then the reverse, normal, reverse, and we can make a composite picture. Now, absolute dating methods. And this is just a few examples. The most, I think, popular and most well-known is radiocarbon dating. This is using organic material like charcoal, wood, bone, anything that's organic. And then we have other methods like tetrachronology, luminescence dating, uranium series. I won't get into the details, but what I want to highlight is two things. One thing is that you choose the method depending on the type of site it is and the nature of the material you're going to sample. The second thing is that all of these methods have limitations. So radiocarbon dating has a limitation of 50,000 years because the elements that you're actually looking at, they decay over time. So if you're looking at 1 million year old artifacts, you're not going to use radiocarbon dating. But radiocarbon dating of the samples from that site will tell you that the sediments are older than 50,000. Then you have luminescence dating, which is very accurate sometimes. And then you have, for example, potassium argon, which you can use for dating ash, volcanic ash. So just some examples of absolute dating methods. And then we put those together, relative dating and absolute dating, we put them together and we can get these kind of information pieces here. So we have stratigraphy, which are different layers. We have fossils of animals and humans. We have archaeological evidence, and we can put them into different layers and build a composite or comprehensive picture to see which things are older, which things are younger, how are they related to different layers, which context do they belong in, for example, where the reversals have taken place, all these things. Also, how much time is missing from this section? Because each layer is not always continuous. Sometimes the river will wash away the sediments and your 10,000 years is gone in one flood. And finally, we come to the environmental aspect. Using geological methods for reconstructing past habitats. We can use flora, like pollen. We can use fauna, like animal fossils. We can use geochemistry, like stable isotopes. And sedimentology, looking at the particles of the sediments, the grain size, for example, to understand the type of deposition, whether it was a lake environment or Loess sediments. So we also look at modern analogs, of course, that's the best proxy. For example, some places like Himalayas, some places in East Africa, some places in South America, the landscape, the wildlife, the topography, the vegetation, these things have not changed for millions of years. They're still continuing the same. So those are good analogs or good examples we can use to interpret the archaeological evidence. Then we have the animal fossil evidence. And why this is useful is because if we're finding a site with hippo bones and crocodile bones, we know it was a water body. But if we're finding a site with deer bones and zebra bones, we know it was a grassland. If we're finding a site with monkeys, we know it was a forested environment. So we know that based on the animal types, we can say some broad things about the habitats. And then looking at geochemistry, looking at pollen, and combining that with, for example, GIS software to reconstruct the landscape. So if you have animal fossils, we have a good sequence of sediments, we have the pollen evidence, we have the geochemistry evidence, we can build a more complete picture. Here's the scene from East Africa of what I'm talking about, an analog, because some of these landscapes have not changed for millions of years. The savanna, the wildlife, the climate. And here's an example of where different animal species are showing a similar habitat. So all these lists are coming from all over the world. One is coming from, the Dalmanisi is coming from Asia, Europe. Bouvardia is coming from Levant. Sangirwan is coming from Southeast Asia. And then we have the Pinjore Formation from India. So these are lists of animal species. And what I want to highlight is all of these sites across the world show a similar habitat, forested environment, grassland environment. And the first three sites have yielded human fossils, except the Shivalik fauna on the right. All of these other sites have yielded human fossils. That means in the Shivaliks, we have the potential of finding human occupation because the environment was same as other places. And then looking at stable isotopes. You know the famous saying, you are what you eat. Well, same with animals. If they're eating plant material from a forest environment, and then you test their teeth for isotopes, you're going to get a C3, carbon-3 signature. But if you're looking at animals that are living in a grassland or savanna environment, and you look at the isotope from their teeth, you're going to get a carbon-4 signature. So you have different types of stable isotopes, carbon, nitrogen, oxygen, to tell us about the past vegetation and past habitats and past environments. We can also do stable isotopes on ostrich eggs. They tell us interesting information about the environment in which the ostrich lived. So even though we know the ostrich was adapted to arid zone, they moved around in the landscape a lot. So this also gives us information. And then shell. We can use shell for dating purposes, for stable isotopes, also for understanding the environment, whether it was a pond or a lake or a stream. And then we can also look at the sediments for stable isotopes, the kankar, which is a calcium carbonate nodules. So you have multiple sources for stable isotopes. And finally, getting all that information, you would have a hypothetical reconstruction of different animal life, vegetation, the landscape, the ecology, the possible climate, all these things. The more proxies you use, the better. So speaking about proxies, I just want to give you an example that you have 2 or 3 dozen proxies, not just fossils, not just pollen, not just stable isotopes. You can get information from cave deposits, from borehole data, historical records, insect fossils, tree rings, ice cores, many sources of information that you can get for past environments and climate change. Corals also, submerged ocean floors, which are now above ground. An indirect proxy also is there, human behavior. So archaeological evidence is an indirect proxy to understand past climate change. So if there was change in the environment in the past, humans adapted. So if you're looking at a sequence of culture at one site, it has 10,000 years represented. You can actually look at a change in archaeology over time. How were the artifacts at 10,000 years ago? How were they 8,000 years ago, 5,000 years ago, 2,000 years ago? What environmental changes happened that led to the cultural changes? Another example, becoming bipedal, so walking on two legs the last 7 million years from living in the trees. Why did this transition happen? We use geology and geochemistry and vertebrate paleontology to understand these changes in the landscape, that the forests reduced in Africa, the grasslands increased, and gradually that enabled or encouraged bipedalism, or walking on two legs. Of course, there were other factors also, but this is one major factor. And then looking at how artifacts and sites are situated in changing environments. So this is a site in Israel, and based on excavations, we found out that the ancient humans were settling on the landscape according to the margin of the lake. Whenever the lake waters receded, they moved closer to the water. Whenever the lake expanded, they moved further away from the lake margin. So you have the adaptation to landscape changes based on geoarchaeological investigations. And then looking at climate, whether an environment was dry or wet, and how that affects populations, how that affects migrations in one area, dispersals of species, extinction of species, for example. And when I say extinction, animals have died in the past because they could not adapt fast enough. You have an option of adapting, you have an option of moving to another area, or becoming extinct. A very interesting phenomenon for environmental studies is that the Toba super eruption. This Toba volcano in Sumatra, you can see on the right. At 74,000 years ago, there was a major eruption, super eruption. And all the ash got deposited in the Bay of Bengal and other places, and in India also. And today, this ash has been found all the way in Africa, South Africa and East Africa. And we are asking major questions about how this huge volcanic eruption 74,000 years ago affected the ecology, the atmosphere, the vegetation, the soil, the water quality, animal life, and indirectly, how did it affect human populations? Did it affect technology, for example? So these are major debates going on right now, and we're using geoarchaeological methods to address these questions. There's two sides to this debate. One is saying there's minimal impact, and one is saying that there's major impact of this super eruption on human populations. But we need more research to find out. A recent study by my colleagues and I, we tried to understand the age of some of these species. So you'll find a lot of fossils, animal fossils in our subject, and now they're extinct. We're trying to understand the reasons for extinction and also their age. So we dated this hippo fossil from Narmada Valley. We got an age of 15,000. So this is the youngest dated hippo fossil known so far in India. And most probably they became extinct around 10,000 years ago. They were here for millions of years, but 10,000 years ago, they become extinct. So we can use geology and related methods to understand factors of extinction, whether humans had a role to play, or was it only climatic factors? Was it change in vegetation? Or if we find enough fossils, maybe we can see evidence of a disease. It's not necessary that environment always plays a role in extinctions. It can also be disease. And finally, I would like to end my presentation by highlighting these cultures to show that we have young cultures that were also impacted by environmental conditions. So we can use geological methods, everything that I mentioned, stable isotopes, for example, ancient pollen, the type of sediments, changes in archaeology, to look at younger cultures also, not only Stone Age. So from Neolithic onwards, we have these terminal Stone Age cultures and then Bronze Age cultures, historical cultures, medieval cultures, everything. For example, all of you are familiar that climate change is affecting us today as well. Glaciers are melting, sea levels are rising. So we can actually get a lot of information about past cultural adaptations and responses to these changes by using geology and trying to understand exactly how these cultures adapted. Some places, they change their technology. Some places, they abandon the sites. In some places, they shifted somewhere and then came back. So we have the Harappans in Northwest. We have the painted graver culture, Ganga Valley Neolithic, Northeast Neolithic, the Ahar Banas culture in Rajasthan, Southern Neolithic. So you have a lot of the Deccan Chalcolithic. You have a lot of these cultures in the last 10,000 years. And then in the last 5,000 years, you have a lot of these cultures that are contemporary with each other, sometimes interacting with each other. So how can we use geology to address these questions of interaction, of environmental adaptation, of culture change? Many factors are there that we can answer. And finally, I'd like to end with two more things we can learn from geology. Besides the three things I showed you, context, age, and environment, we can also use geological methods to learn about human behavior. For example, in the Stone Age, they were using different types of rocks. We can actually characterize a rock, make a thin section, look at the petrology of it, look at the nature of the rock, to see exactly what the rock was made of and why the hominins in the past, the human populations in the past, selected one rock over another rock. Why did they use quartzite? Why did they use basalt? This is kind of a question that is answered only by looking at scientific analysis. So this shows exactly preference of the rocks, selection of specific rocks at different times in prehistory. In my area, in Narmada Valley, we have basalt available and quartzite available, but they used only quartzite. They did not use basalt. But in Maharashtra, in the Deccan Plateau, most of the Acheulean sites are made on basalt because they had no option. Basalt is dominant. But when they had a choice, they chose quartzite in Madhya Pradesh. And then we have geochemical properties of rocks to find their original source. Things like X-ray diffraction, X-ray fluorescence. These kind of methods in geology we can use to pinpoint the source of the rocks, or even the source of the clay that is used to make pottery. Then we can find out how many kilometers they traveled to transport these raw materials. It could be rocks, it could be clay, back to the site. So sometimes in prehistory, we have evidence of hundreds of kilometers of transport, especially rare rocks like obsidian. So your cave is in one location, but the obsidian is 200 kilometers away. So you go to the obsidian source, bring back the obsidian to your cave, and make the artifacts. And here are some examples of different types of rocks. We have the limestone from Hunsgi Valley of Karnataka on the bottom. And we have these quartzite cobbles and pebbles from the Shivalik Hills of Himachal Pradesh. So you can see a huge variation in the nature of the rock, the size of the rock, the shape, the quality, everything. So they chose these rocks in the past to make different types of artifacts. And when they couldn't find good rocks, they adapted to inferior raw materials. And just an example to show you different types of rocks: basalt, quartzite, dolerite, granite. These are mainly used in the lower Paleolithic. But from the middle Paleolithic onwards, as the artifacts become more refined and more advanced, they start using fine quality raw materials like quartz, limestone, chert, chalcedony, obsidian, jasper. These things start being used increasingly after a certain time. So in fact, the hominins that were using these stone tools 3 million years ago, 2 million years ago, in our subject, we call them the original geologists because they had knowledge of the rocks, they had knowledge of the landscape, they had knowledge of the ecology, and they knew exactly what to look for. So thank you very much for your attention. And I have given my email address in case anybody has any questions afterwards and they would like to ask something. And we could even have some discussions now if we have time.
That was really enlightening lecture by Dr. Parth Chauhan. And I'm sure that there would be many questions from our participants audience. If anybody has any question, kindly put it in chat box so I can read it for you. Many has said it is a wonderful journey through time. Vaneshri says, a great talk. I had a question. Is there minimum specific standard of disturbance for a site to be classified as primary or secondary context, since no site is 100% primary context?
Yeah, that's a good question. Actually, there's no specific criteria like that. What we usually do is if you're finding fresh artifacts and if things are refitting and is coming from fine sediments, then we just call it primary. Even though we know that it's not 100% primary, it's classified as primary based on arbitrary criteria.
Right. Mr. Shankar says, a fantastic presentation, shows his ideas are clear in his mind and came out very clearly. Thank you very much, Shankar sir. Bhalchandra Bhalerao sir says, fantastic lecture. Kajale sir says, very nice presentation by Dr. Parth showing interrelation between archaeology and geology, useful for people from both disciplines.
Thank you.
Ajit sir, would you like to add something?
I think it was a really wonderful talk, Dr. Parth.
Thank you. Thank you.
And actually, when we were planning to have somebody to talk on this subject, the first name was yours only.
I see.
I know that nobody will accept this person to talk on this subject. And without any hesitation, we immediately agreed to give a talk. That was really fantastic. And the way you presented it was really nice. I think, Pathak sir, I think we can unmute Savarkar sir to give some.
Yes. Savarkar sir, can you unmute yourself, please? I'm sending on the request.
ಅಜ್ವಲ ನಾನು ಕಾಮೆಂಟ್ ಕೊಡಬೇಕಾದ್ರೆ ಏನು ಹೇಳ್ಬೋದು?
Yeah, he's there now.
Naidga?
Savarkar sir, are you there?
Yes,
Yeah.
yes, I'm there.
You can just share some words.
Because Savarkar sir was, as I told you, he was director for Central Wildlife Institute at Dehradun. Sir, please.
Actually, this has been one of the most wonderful presentations that I've heard. The important thing is convergence of two great branches of science in order to take us through this long journey. And, you know, I go back to the book that I had read earlier on. This was Collapse by Jared Diamond, who in several pages shows this kind of convergence of science. And thank you very much, sir. This has been a wonderful experience. What I would say is that, well, I did geology long time back and at bachelor's level, but many of the terms came back to my mind. And I would say even for lay persons, this was very, very great kind of presentation. Thank you very much.
Thank you.
Pathak sir, I think now you can unmute. Pathak sir, can you unmute now Dr. Mohabe?
Mr. Prakash has something to say first. Let us hear him. Mr. Prakash?
Yeah, good evening. It was a very nice presentation. Congratulations for a lucid talk. I have one question. Mr. Partho, you have worked in Narmada Valley. I have also worked in Narmada Valley for 5 years, mainly for geological mapping of Khargone and Converge states. And a colleague of mine from Bhopal, Mr. Arun Sonakia, who brought out Narmadensis from one site, You can elaborate on that and why we do not have such repetitions elsewhere in the Narmada Valley or elsewhere in the country of that particular age and particular humanoid. So why it is only a single occurrence?
Right. That's a very common question many ask me. So we have actually, I started the Narmada research by starting at Hatnora, where Dr. Sonakia found the fossil. So our goal was to date the site and find more fossils. Now, we dated the site, we got a minimum age of 50,000 roughly. So we know that the deposition is 50,000 years old, but the fossils could be much older. So we need to date the fossil directly. But why we're not finding more fossils in India? There's good reasons for that. Number one, I would say, is that people have not looked actively. Like, for example, what happens in Africa and other places, experts in human fossils actually go for field work and they're surveying for fossils. So when they find the human fossil, they recognize it. But archaeologists, if we find human fossils, we won't recognize it as being human. That's one factor. So we don't have enough experts in India to be in the field looking for fossils. And we need to use more contextual strategies. In fact, geology, remote sensing, to actually target specific zones. If you look randomly, we're not going to find the fossils. But if you look strategically, looking at the vegetation patterns, geological patterns, where the animal fossils are being found, then we can have increase the chances of finding human fossils. And also, I think we should focus on cave sites also, not just open air sites. So we are working in Narmada actually just to find more fossils. And I think over time, we should find them.
Okay, one more question.
Yeah.
You mentioned about Toba super volcano. We have got, ash depositions at some places. Here near Bangalore, near Gauribidnur, there's a place where we have got the white ash layer between two red soil horizons. That is supposed to be of Toba. Toba was 74,000 years ago. In 1815, there was Tambora super volcano eruption,
Yes.
which is supposed to be VEI 7.
Yes. Yeah.
Index 7. What are its telltale effects in India or evidences in India? Have you come across anything like that?
Nobody has studied that yet. Actually, Toba volcano, there were multiple eruptions in the past, going beyond 1 million, but 74,001 was the largest. So at the moment, we have two types of evidences, and we need to look at it from a regional perspective. So we cannot say that whether it had an impact in India or not had an impact in India. We have to ask a different question. We have to ask how much impact did it have in South India? How much impact did it have in Central India, in North India, like that? But the younger volcanic eruption you're talking about, I don't have information about that, but I think there must be some hypothesis how much impact it had in the regional environment. But I don't think it was as large as Toba eruption.
No, Tambora and Krakatoa are supposed to be very large eruptions in the recent times.
Prakash, excuse me. There are many people who has something to say. If you want any specific question elaborate, you can contact directly Mr. Parth. Okay. Thank you very much.
Thank you very much.
Yeah, please email me. Yeah.
Mr. Aditya Shankar has one question. How is topology related to this subject?
So typology is basically looking at change in archaeological nature. So let's say we have mobile phones. I'll give a modern example. If you have mobile phones, and in the past, we were getting the small Nokia type, and then they were making the flip phone. And today we have the iPhone. So different, over time, the artifact is going to change. And we can use that information to look at culture change, of course, but also impact of environment. For example, in Harappan pottery, when the environment became dry and when the environment started impacting the populations, you can notice that in the quality of the pottery. If you look at the change in the pottery quality, the change in the clay, the change in the style, the quality of the pots, all these things, you can see that there's a correlation between environmental change, economic change, and cultural change. So typology is very important to look at change over time.
Okay, there is one Mr. Imam from Calcutta University. He says, I have question regarding the geo-archaeological studies in medieval history. What is the scenario?
Okay. So in medieval times, and even up to early Holocene, which is Harappan times, one thing that we can look at is how floods affected these sites. A lot of these medieval sites have evidence of floods. So sometimes we have evidence of site abandonment and then again resettlement. So that we can look at in medieval context.
Yeah, thank you very much. Many have praised the lecture, great webinar, the very informative, interesting research and work and presentation skills, etc., etc. Ajit sir, anything specifically you wanted to add?
I think Shankar sir also has asked, I think, some question.
Yeah.
Yes, please, if I may.
Please ask, Mr. Shankar. Yeah, please.
Okay. Parth, once again, congratulations on the excellent presentation you made. I'm sure your students must be loving you, aren't they?
I don't know about that. I don't know who you asked them.
I have a question. It's about, pottery. I read somewhere that, you have black pottery, red pottery, and depending on the type of pottery we see, they said the typology and all that, how can we make out that this particular pottery, red or black, is from a certain age? Of course, you already gave an example of cell phones, but specifically with respect to pottery, can you please educate me?
Okay. So the color of the pottery can be affected in different ways. The first factor that affects pottery is the clay that is being used. Where you're getting the clay from? Does it have a lot of iron content? What was mixed with the clay before the pottery is made? The second factor that affects the color is the firing part. When you're actually heating the pottery. If you overheat it, it's going to be darker. If you underheat it, it's going to be a different color. And the third factor that affects the color is what happens to the pottery after discard. So once it's discarded, after discard. So if it's buried in the ground, and depending on the nature of the sediments around the pottery, that can also change the color of the pottery. So that's these are all factors affecting the color. But if you're looking at change and trying to understand the age, so in some areas like Northwest India, we have a lot of lengthy research history. So we know the pottery looks like. If you find a Harappan pot, we know that which period it belongs to, whether it's early Harappans or mature Harappans or late Harappans. But let's say that we find pottery that has never been found before. How do we know the age? So one thing we look at is whether it was handmade or wheel made. If it's handmade, it's probably older than 3,000, 4,000 years.
Yes.
Neolithic maybe. But if it's wheel made, it's younger. But the best way to date pottery is thermoluminescence. We can date the pottery directly by using thermoluminescence and get an age.
Just one last question.
There's a limitation with that. As long as the pottery is only fired one time. If it's fired twice, if there's a fire at the site, the pottery gets burnt again, then it's going to give you the younger age.
Yeah, it will reset.
Yes.
Now, just one question.
Yes,
how
please.
come the black pottery remains black even after firing? Why doesn't it turn red or brown?
It depends on how much is fired. Depends on the two things, the temperature, as well as what fuel was used. Whether it was cow dung, whether it was wood, for example, whether it was in an open fire or inside a kiln, inside an oven. All these factors will affect it.
So higher temperatures would have produced, reddish or brownish color, right?
Yes.
Okay. Thank you so much.
But if the kiln doesn't have enough space for oxygen, then it won't become oxidized. It needs oxygen for becoming reddish.
Exactly. Yeah. Thank you so much.
Thank you very much, Mr. Parth. I will take last question from Shivani Madam. I have a question regarding floods destruction. When the floods destroy the whole things and the whole section gets washed out, is there any other way to make a correlation for the loss?
That's a good question. Usually, if the entire evidence is dispersed, if it's washed away, then we have no preservation at the site. But one thing we can look for is downstream. The material that has been removed from location A might have been deposited in location B. It could be 100 meters away. It could be 500 meters away. So we can look at things downstream to use that information and build up the story upstream. But in some cases, it depends on the nature of the site. Sometimes only 50% of the site is destroyed. Sometimes 95% of the site is destroyed. It depends on the nature of the site. And if you get away from the river, you might find more evidence that is intact. Only the site near the river has been destroyed, but the inland rivers, the inland sites are intact.
Yeah, thank you very much. Now, since we have,
sir, I think, sir, we can unmute Sudha also. Sudha.
Yeah, Sudha madam, are you able to unmute yourself?
Yes, sir.
Yeah,
Parth,
please.
I would like to just tell about Sudha. She has done PhD from Deccan College. Basically, she is a geologist, but she has got this angle of archaeology because she has worked under Dr. Rajguru.
Oh, very nice.
So I request her to say something.
What can I say? Actually, it was a very informative lecture. You took us through the whole process very systematically.
Thank you.
Yeah, and one question. I mean, not a question, actually a query. Like I often hear the term patina.
Yes.
So can you just elaborate? I mean, explain it to us. Okay, what when the archaeologists keep telling about patina, what exactly it means?
Sure. So any rock that is on the ground and also a rock that is buried, it goes through different processes of change. So you have a rock on the ground is affected by sunlight, affected by rainwater, affected by surface chemistry. And the rock inside the ground is affected by the geochemistry. So any geochemical factors affecting the surface of the rock, that's going to create a new layer. So if you break the rock, it's going to be fresh inside, a different color. But if it's buried for several thousand years or several million years, that broken part will again get covered by a new layer. And that is patina.
So something like a weathering rind.
Yes, kind of.
Okay.
Very similar.
Okay. Yeah. Thank you so much. It was a very, very lucid talk. Very informative, really.
Professor Rajguru was my teacher also when I did my master's at
Oh. Okay. He would have loved to join, but he has a problem.
Yeah.
He needs help. Yeah.
Yes.
I wonder if I can speak a few words.
Yes, sir. Please.
Yes, please.
This is Bugun Kazare. Of course, I was working in Deccan College, and I still remember Parth Chauhan. He was our student almost 25 years back or something like that. 96, 97 batch, if I remember correctly.
Yes.
And very nice to see the evolution in Parth Chauhan's presentation. This was very methodical presentation, very systematic presentation, and he was talking very slowly, very confidently, and I'm very pleased to hear our student showing a great maturity and explaining the things in a manner which would be understood not only by the archaeologists and geologists, but also by those people who are not from these disciplines. So my best wishes to Parth, and keep progressing like this. And also thanks to Ajit and all the team members for arranging this lecture. All the best.
Thank you so much, sir. Thank you so much. It means a lot.
Okay, there is another lecture lined up, so I have to conclude this meeting. A very nice talk by Dr. Parth. Thank you very much. Ajit sir, you can conclude.
Tomorrow we have a lecture, and tomorrow we'll be celebrating a map day. So we'll have Dr. Sanjeev Nalawade, and he'll be talking about reading a map is fun. He was a professor and head of a department at Ferguson College, Geography Department. And tomorrow he'll be talking about reading a map is fun. So tomorrow at the same time, 6 p.m., we'll be meeting on the same platform on the Zoom. So you'll get the link and other thing. So we'll meet tomorrow.
Okay then. Thank you very much.
Okay.
Good night.
Nice meeting Professor Shankar as well as Sudhaji and also the